In this class, we are going to continue the discussions or learn in the conic sections and special curves, in which the methods of construction conics, that is construction of conic sections, construction of ellipse, construction of parabola, construction of hyperbola, and involutes, spirals, and cylindrical curves. These are all you are already discussed. Now, in which the last chapter is cylindrical helix. So today we are going to discuss cylindrical helix. Now, cylindrical helix. It is defined the locus of a point moving around and along the curved surface of cylinder with combined uniform angular and linear velocities about and in the direction of the axis. This will going to learn with the problem number 13, that is plot on complete turn of cylindrical helix of 55 dia and 65 mm pitch. Now draw the development also. Now let us start with a circle with a given dia of 55 mm to represent the top of the cylinder. That is top view as just like circle, which will be represented as a cylinder as shown here with the circumference. Pitch is like that. Now, in alignment with the top view, draw a rectangle of sides equal to diameter of the pitch of the required helix as shown in figure. That is the cylinder, that is the top view, which will appear as like circle, and in front view it will appear like a pitch or square. Let us observe the development of the front view. In alignment with the top view, draw a rectangle of sides equal to the diameter of the pitch of the required helix as shown in figure. Now divide the circle into 12 equal parts and name the division points as 1, 2, 3, etc. in the counterclockwise direction. Now draw vertical lines through these division points to the front view. Now draw vertical lines through these division points to the front view. Thus divide the pitch into same number of equal parts 12 and name the divisions 1 dash, 2 dash, 3 dash, etc. Now draw horizontal lines through these division points into the development surfaces. Now, in the initial position of tracing point will be at division point 1 in the top view. Now, to get the new position of the tracing point on the curved surface of cylinder in front view, draw a vertical line through 1 to intersect the horizontal line through 1 station at P1. Now, to get the next position of the tracing point on the curved surface of cylinder in the front view, draw vertical line through 2 and 10 to intersect the horizontal line through 2' to P2. Similarly, obtain P3' and so on. Now, draw a smooth curve passing through these points, which will appear like a helical curve. In the second half of the revolution, since the tracing point moves in the raised side of the cylinder, the helical curve passing through points P6 through P12 is shown in dotted lines. Now, if the helix is rolled on plane, the helical curve becomes a straight line AC as shown in figure in the developmental line. That is, if helix is rolled on the plane, the helical curve moves a straight line AC as shown in the developmental surface. Now, the portion below the helix becomes a right angle triangle. Now the height or altitude of triangle is equal to the pitch and the base length equals to circumference of cylinder. Now the straight line AC represents the helix and the inclination of AC with horizontal is equal to pi and called as helix angle. Now, the right angle triangle ABC is called the developmental line. Once again, now you come to the repeat. Draw circle with the given dia of 50 mm D to represent the top view of the cylinder. Now divide the circle in the top view into 12 parts and name the divisions points as 1, 2, 3, etc. in the counterclockwise direction. Now draw vertical lines through these division points to front view. Now divide the pitch also into the same number of equal parts, 12, and name the regions 1, 2, and so on. Now draw horizontal lines through these division points. Now the initial position of tracing point will be at division point 1 in the top view. To get the position of tracing point on the curved surface of cylinder in front view, draw vertical lines 1 to intersect the horizontal line through 1 dash to P1. Similarly, to get the next position of the tracing point on the curved surface of cylinder in the front view, draw a vertical line through 2 and 10 to intersect the horizontal line through 2 dash to P2. Similarly, obtain P3 dash and so on as shown in figure. Passing through these points, draw a smooth helical curve. In the second half of the revolution, since the tracing point moves on the rear side of cylinder, the helical curve passing through points P6 to P12 is shown in dotted lines. In the helix is rolled on plane, the helical curve becomes a straight line AC as shown in the development. Which will be measured from now we will get a triangle. This portion below the helix becomes a right angle triangle, and here the height or altitude of triangle equal to pitch and the base length equal to circumference of the cylinder, that is pi d. The straight line AC represents the helix and the inclination of AC with the horizontal is equal to pi and called as helix. Now the right angle triangle ABC is called development. With this concept, the conic sections and special curves last topic, cylindrical helix, is completed. Now, get back. Now continue. So, after the completion of this chapter, first how we can evaluate the study or memorize data. Now let us solve the question or give the answer to this point. A tangent to conic draw from a point from the dash. So what it represents? First you understand. Tangent to conics draw from a point from the directrix, ordinate, vertex, none of these. Ordinate, because it is not a ordinate. Tangent to conic section draw from point. So ordinate is a line and vertex is a line, but the tangent should not be drawn from a vertex, and the tangent can be drawn maybe not maybe directrix. So the answer is directrix. Now let us see how. Right, that is tangent to conic drawn from point from the directrix. That is the correct answer. Now next evaluate second one. In this question, in a rectangular hyperbola, the asymptotes are always perpendicular to each other. Options are true or false. See in a rectangular hyperbola, these asymptotes are always perpendicular to each other. So the second is, I think it is true. Right. That means in a rectangular hyperbola, the asymptotes are always perpendicular to each other. It is correct. Now next, third question. In involutes is the locus of points from the dash. Third question. In the locus of the point on the inextensible string unwinding from around a circle or polygon. True or false? Once again, involute is the locus of the point on inextensible string unwinding from around a circle or polygon. Yes, it is correct. That is true. Now next, fourth point. When a section plane cuts the base and passes through the apex of the cone, then the section obtained is ellipse, isosceles triangle, hyperbola, parabola. Fourth one. That is isosceles triangle. Here, when the section plane cuts the base and passes through apex of the cone, the section obtained is isosceles triangle. Now this one. If the major axis and focal points of an ellipse are given, then which method you will prefer to construct an ellipse? That is major and minor axis. No, major and focal points of ellipse are given. Then which method will be preferred to construct an ellipse? That is concentric circle method or rectangle method, interfacing arc method, parallelogram method. Concentric circle method, you have to give that two major and minor axis, and similarly rectangle method and parallelogram method, and okay. Now let us put this interface arc method. Right. If the major axis and focal points of ellipse are given, Then which method will be preferred to construct ellipse? Now it is correct. That is interfacing arc method. Now we'll move to sixth question. In this, the distance between foci could be found if we know the length of dash. That is major axis, minor axis, both the axis or eccentricity. Which one? The distance between foci could be found if we know the length of dash. Evaluate. No, it is both the axes, that is major and minor axis. Wait. Now next, seventh one. The tangent plane and section plane meet in a line called directrix. Major axis, minor axis, none of the above. That is a directrix. Why? Because the tangent plane and section plane meet in the line called directrix. Now next, eighth one. Eccentricity of parabola is always equal to 1. Is it true or false? Because it is true. That is, eccentricity of parabola is always equal to 1. Now move to next question, 9th. Encyclopedia's epicycloid is a curve involving two circles when one of them rolls on the outside of the other fixed circle. This is also true. Yes. Epicycloid is a curve involving two circles when one of them rolls on the outside of the other fixed circle. Next one. Last. If the section plane makes a similar angle with the axis of cone, then the generator's section obtained is rectangle, hyperbola, parabola, hyperbola, ellipse. No, it is a hyperbola. Now, if the section plane makes similar angle with the axis of cone, then the generators and the section obtained is hyperbola. Now, you come to the self-evaluation. After completion of self-evaluation module, now go to review questions, that is examinations questions. Now you note down all these. After this, we'll move to next one. First question. The minor axis of ellipse is 70 mm and the distance between the focal points is 70 mm. Using a geometrical construction, draw this ellipse full size, showing all necessary construction lines. Second question. Construct any different methods to ellipse, each with major axis 90 mm and minor axis 50 mm. Mark any point B anywhere on the curve and draw tangent and normal to the ellipse P. Third question. Construct an ellipse having an eccentricity of 3/4 and focus 25 mm from directrix. Measure its major and minor axis and the distance between its two foci. Fourth one. Construct an ellipse having a major axis 80 mm and minor axis 60 mm. Locate its foci and directrix and find the value of eccentricity. Fifth one. Construct parabola which has its focus 30 mm from its directrix. Draw the tangent and normal at a point on the curve 60 mm from the directrix. Now review the questions on conic sections and special curves. Sixth one. Construct a hyperbola when the distance of its focus from its directrix is 60 mm and eccentricity is 3/2. Construct a parabola using locus method which has its vertex 20 mm away from the directrix. Draw a parabola with its axis vertical in the rectangle 120 mm high by 110 mm wide. A hyperbola has its vertex 10 mm from the directrix and its focus 18 mm from the vertex. Draw the curve using the locus method. Draw a rectangular hyperbola having a point P on the curve 15 mm from the vertical asymptote and 65 mm from the horizontal asymptote. In this chapter, we studied completely now we move to the previous one. That is summary of the conic sections and special curves as below. The method of constructing conic sections, that is construction of conic sections.
Draw the directrix of suitable length in the vertical direction shown in figure. Draw the axis perpendicular to the direction. Now, mark the focus F on the axis such that CF is equal to 45 millimeters. Procedure for drawing parabola. Eccentricity is equal to 1, that is equal to Mn by Cn. Select any point M of any length from T on the axis and draw a perpendicular line Mn so that Mn is equal to Cn. Join Cn and extend it. This is called eccentricity line. Through S, draw two lines at 45 degrees to cut the eccentricity line at S. To cut the axis at A in one direction and in the other direction. The 45-degree line will be parallel to the eccentricity line. General procedure. Choose number of points 1, 2, 3, etc. arbitrarily on the axis beyond the vertex A. Draw the perpendiculars to the axis to extend on either side of it at 1, 2, 3, etc. To cut the eccentricity line at 1 dash, 2 dash, 3 dash, etc. With S as center and radius 1 to 1 dash, cut the vertical line drawn through 1 dash at P1 and P1 dash. Again, with F as center and radius 2 to 2 dash, cut the vertical line drawn through 2 at P2 and P2 dash. Similarly, obtain P3 and P3 dash, etc. Passing through A, P1 dash, P2 dash, so on, A, P1, P2, so on, draw a smooth curve. Draw the directrix of suitable length in the vertical direction as draw the axis. Now, mark. AB is the given line 20 millimeters length. With center B and now with center A and radius AC equal to R3, draw the semicircle CD. With center B and radius BD, that is equal to R3, draw the semicircle DE. With center A and radius AE equal to R4, draw a semicircle EF. Similarly, continue with centers A and B alternately till the required number of turns is obtained. A2 is the given line 20 millimeters length.
Now, maybe in the next chapter, what we will give you a little bit of introduction.
Learning objectives. After completion of this chapter, you will be able to know the meaning of orthographic projection, know the various views of an object obtained in projection, drawing the front, top, right side and left side views, classify the visible and invisible parts.
Engineers are mainly involved in the design, development, and manufacture of machines and environmental structures. What is going to be the very first step is to prepare a drawing of the machine or structure to provide the details of the design like the shape, the size, and so on. To have complete representation of such a three-dimensional object in the drawing, the object is viewed from different directions. These are typically the front view, the top view, the left side view, and the right side view. And these views are called the orthographic views of an object.
Now we will discuss in depth orthographic operations in separate class.